Okay, we're going to start talking about the formula to calculate investments when the compounding is on a continuous basis. Now, this formula is also used as a growth model, not just for money, but if we were talking about money growing continuously, some sort of population growing continuously, whether it's like a bacteria or even human population, or something potentially decaying on a continuous basis, we could use this formula to do that. So it's not just money that we would use this for, but primarily when we talk about how to work with it, investments work well because we are able to comprehend the idea of investing money. So real quick, let's talk about our variables here. What do we have? So this is really A of t, which is your amount of money at a certain time. Okay, so it's the amount, it's the future amount. P is our principal, right? It's our initial. Okay, E is a constant, right? And that is which is 2.7182881, so on and so forth. Okay? We're going to use the calculator to plug in the values so that way you get the most exact possible answer. And then let's move this up a little bit. R is equal to our rate. Remember, it's a decimal. And then T is our time. Okay? So those are the pieces of the formula. So now let's go ahead and do an example and apply this formula. Okay, so we have Caitlin who invests $2,000 at 6.5% interest. It is compounded continuously. What is the value of her investment after 5 years? Okay, so first things first. When I start doing these problems now, I got a couple different types of growth. Now that we have continuous growth, the minute you see that, you got to think I'm using E. Right away, you write down PERT is what we call it. Principal times E raised to the RT, PERT. So this is what our amount is equal to. So in this problem, P is equal to 2,000. R is equal to 0.065. Make sure you convert the decimal appropriately. And T is equal to 5 years. So amount after 5 years is equal to 2,000. E raised to the 0.065 times 5. Be careful that when you plug this into your calculator, this whole thing is in parentheses if you have the older software. A of 5 is going to equal $2,768.06. Round to the nearest cent. We don't have partial pennies, so you must round to the nearest cent. And that's how we apply this continuous formula. Once again, this could be used for growth. We could adjust it for decay. So it's used for any type of continuously growing or decaying situation.